We'll wait about another minute or so. Get a few more people come in. Hey, my name is Dale Duell. I'm an application engineer for Solid Edge and CamLogic. Today's web session is entitled Solid Edge Smart Parts. We'll learn about those in just a second. Tech Tuesday is provided to you by CamLogic. We were founded in 1996. We're headquartered in Oxford, Michigan. We serve the Ohio, Pennsylvania, Indiana, and Michigan area. We are a complete Siemens business partner, a complete reseller of the Siemens engineering products, and that would be the NX, Solid Edge, FEMAP, and Team Center. But we do more than that. We also do printers with Z Corporation, laser scanning. We also do analysis and a few other CAD packages CAM packages as well to finish out the suite of offerings that we have. We also provide training. We are professionals at everything that we sell. We are able to train, so we want you to be able to feel comfortable with the product that you have from us, and we want you to be able to get the best out of you can. In order to do that, we provide training either on-site, that is at your facility, or one of our classrooms throughout the territory. And we also provide customized training too. We understand that not one size fits all. So we want to be able to round out your experience with our software. We also offer the best technical support we can possibly offer you, and that is our experience and our knowledge and our connections also with the developers of each software package or each program that we sell. So we actually are planning and hoping that you'll see that we're more than a reseller. We're more than just a store to where you get your software or your hardware for the scanning. We want to be your support specialist. We want to be that person on the other side of the desk. We want to know what your processes are, maybe even what your political situation is at your facility, or anything that requires for you to know more or to do better with that software. We want to know those details. We want to be a part of your experience with the software, not just a source to where you go and you've bought it. So with that, I want to start talking about Solid Edge Smart Parts. Now, Smart Parts is my term. It's not a Solid Edge term, but it is my term. And what it allows us to do is to make parts that are repeatable and reliable. So if we take a part that we're going to maybe use again, or we're going to have a part just like it, only slightly different, we want to save those parts off. We want to make those repeatable and reliable. We also want to use proven design strategies when we do this. We don't want to half design something, leave something out there to chance, and then try to figure out how to build that part later on. So we want to build those design parameters into the part. Having done that, once we do that, I always tell people, if you give me 5 minutes now on your first part, your second part can come in 5 seconds. So we want to be able to use the intelligence, use the design intent that we already captured the first time around. We want to save that off, make it communicate that, so we can go use that again. So having said that, we'll go ahead and get started. Just a brief example of what a smart part would be. I've got a plate. I'm going to design a plate here just very, very quickly, and I'll just show you what I was talking about. Very, very simple plate. I'm in the Solid Edge ordered environment. You can do this in synchronous as well. And I just want you to see this plate right here, and we'll make it 5-inch by 8 inch. And we'll make this plate a 1/4 inch thick. So we can already see that the parameters are starting to show up again with this, in that we have a 5 by 8, and on the side over here we can see that we have a 1/4 inch thick. So we see that those design parameters are already there. So we might go ahead and make a cutout out in this plate of a certain size. We'll go make that 2 inch, and then we'll position that the way we want to. We'll say maybe 2 inch over. And then we'll say maybe 3 inches up, something like that. So again, that hole understands, or that cutout rather, understands what we're proposing here, in that we have a cutout. I'll flip this around. We'll stop the turning. We have a cutout that is 2 inch by 3 inch, 2 inch in, 3 inch up, a 2 inch hole. Now, any one of these can be corrected or can be changed at any time we want to. So I'm taking my middle mouse button and just scrolling back and forth. Maybe we want this 2 inches down. So we want 2 inches over, 2 inches up, 2 inches diameter. So we are taking that, what we already know, and we want to use it as a smart part. We want to take it and include it, all the parameters, so we can use that again. In order to do that, we just simply save the part down at the template level. So wherever your templates are, most people's are out on the hard drive, some they're out on the server on multiple users. You can put your smart parts out there. Now, I've created a few new smart parts myself, and out in my template folder, where I pick most of my templates out there, I have a folder called a smart part folder. And looking at that folder gives me things that I've already laid out in the past. So as I look at my smart parts, I have some layouts I've already done. I've got a cutter, a 3D cutter I've got here. I've got a generic ring. I've got some sheet metal that we use to cover motors and light bulbs and belts and things like that. So instead of drawing that, all I have to do is just bring that up. So Solid Edge also provides, not many people know this, but Solid Edge also provides other things such as funnels and hoods and things like that inside the sheet metal environment. So here is a round to round, here is a square to round, and here's a square to square. Now all of these are completely drivable the way you're going to see me demonstrate this. So I've switched over, and I've got some of my parts, and I'm going to give a live scenario here, and in this case we're talking about conveyors. And I'm going to pull up and I'm going to design a conveyor live in this, hopefully in this brief 10-15 minutes that we have. So I'm going to pull up my conveyor side. Now this is a template piece. It's setting out there. It's a smart part. Those template pieces are controlled or are accessed by our variable table. And I want you to see this, the different types of rules that we have out here. Here's just a limit dimension. We'll talk about that. And then I have a formula, and then I have a discrete list or predefined length, if you will. So I'm going to move this out and just show you very, very quickly how I do this. And I've already got this set out to where I might want this piece 24 inches long. So just by clicking on that 24, the part now goes to 24. Notice that the holes, that we've taken the time to pattern the holes, so the holes are going to follow, because this is what's going to hold the rollers of our conveyor. So if I want a 24 or if I want a 48, I get the exact length I need, and I keep my design parameter that I've been asking for, that it has to be so long and then spaced out every 4 inches. Now, I also get to control, I was talking about spacing, I also get to control the spacing. I've got that set at 4 inches, but if I set it at 5, I would get a different type of spacing. If I set it at 3, I would get more holes in there, and if I set it out at 6, we're going to go get a different spacing altogether as well. So again, I'm controlling this part the way I want to, and the way, you know, my spec sheet or my job or my quote is requiring me to do that. So I may have that with the spacing. Now, with the height of this model, in this particular one, just for illustration purposes, I have a 6-inch height. Now you may notice that this is up in gray. My flange is 1.5 because my formula says it's going to be 25% of my height. So therefore, if I change my height to 5, not only do I change my height, but I also change my flange to 1.25 inches. So if I change my height to 4, I change my flange to 1 inch. Anything like that that you want to set up can be had according to your design parameters that you need. So I'm going to go ahead and save this. And since this was a template, it now comes in, it now asks me, how do I want to save this part? So I'm not overriding the original piece. The original piece is safe down in the template folder. I get to pull this up, use it again. If you see that real quickly, as we go to our Acme parts, here's my conveyor side that's not changed at all. So I'm going to go out and do the very same thing to my roller and save this off before, again with my variables, just looking at this, and I want a roller length that's perhaps 20 inches long and maybe 1.5 diameter. Anything else that I care to change about that, I can change. Maybe this bar stock needs to be a little smaller. We'll see how that plays out in the end. So I can save anything that I like that. So I'm going to go save that, and this is going to become my roller. Well, at that point, we want to go back to our conveyor side and go to the new button, just as we've been doing, but this time we want to go create an assembly. So now this part becomes our first part in our assembly setting out there, waiting for us to finish building that assembly. And I'll take the roller that we have, and I'll bring this out, and we'll go ahead and put this in, and we'll do perhaps a planar line, and we'll say it's going to be a 1/2 inch off of that surface right there, and then we'll mate or put these pieces in place. Zoom in here real quickly. It's going to go there, and I'll mate that piece up to there. So that roller now is going to be in position to give us exactly what we want. Now, I'll take my other conveyor side, that just so happens that these sides are the same. So I'll take my other conveyor side and I'll bring that in. And you see that it comes in backwards, or the same as this part, which is fine with me. Very easy to do that again. I'll just simply planar align this piece, and we'll go a 1/2 inch off of this piece. And then for this reference, we will go planar align this piece up to there, and then this piece to this edge. So now that I've got the start of my conveyor sitting out there, giving me exactly what I want, while I have that, because I've spent that time on patterning and not just putting holes in random and trying to make that work, now very, very easy for me to take this roller and to just simply pattern that roller and put those rollers in right as we speak. So I can put that roller in, and just many times it will fall right into the holes that were patterned in the first place. Now, because we took those smart parts, and because we took the time to give that knowledge that we were looking for, I can now start to work with my assembly even right here. So this is a thing called pure variables. It allows me to look down at this part inside of the assembly as I work on that. So for instance, I might choose now to go, I don't know, maybe 96 inches. And we'll take that out there as 96 inches. And then we might look at this, and I need this at 5 inches tall. Now you'll see the model look like it needs to be rebuilt. It'll automatically rebuild when I'm done with this spreadsheet. And then the spacing, I wanted them every 4 inches. The nice thing about my pure variables is while I'm working with this side, I get to go over and touch the roller. So now I want maybe my diameter of my roller to be 2 inches. Having something like that, maybe I want this 24 inches wide, and so now those rollers are going to be wider. Not to worry, solid edge is going to go out, rebuild that conveyor exactly the way we want to, because each part is corresponding to the variable table or the spreadsheet that we set up for that. So it's going to go out and give us exactly what we want. So we'll take this and then very quickly we worked with a part, we worked with sheet metal, and now I'm going to go do a smart part as an assembly. So I'm going to go take this frame that we have out here and simply go out and run this structural member all over this place, all over this piece right here. And as I have that, it's no problem at all whatsoever to take that sketch and to look at that sketch and to see that that sketch that we've designed at 20 inches, 30 inches, 12 inches right here. Again, we can change that any way that we'd like to because it is running off of that sketch, and we have decided to keep those parameters or put those parameters in when the part was created. So as I have that, now I can take my support and bring it in and just quickly say that I want to take this face perhaps, put it down to there, this edge, put it to that edge, and then I'd like to take this face and bring it 12 inches off of the end. Now, if we see this, we can see very quickly that this is, if we see this, we can see this very quickly that this is not wide enough. Again, no problem whatsoever, because we kept our smart parts, because we used those in the beginning, allowing us to go out and to take the pure variables of that part and just simply change the width of that. If that's 24, let's go ahead and make it 28. Set it out like that. Solid edge is automatically going to adjust itself to that. So these are smart parts. Parts that we use over and over again. They're just like this, only slightly different on the next round. There are more complex parts that we can do, but for a beginning of this, we just want to show you how to do those smart parts, being able to drive assemblies, being able to drive parts based upon proven design parameters, the ones that you've already used. So I want to thank you for your time. I welcome your questions. Please feel free to contact me at DaleD@camlogic.com. Our next training is coming up, Solid Edge Synchronous Technology. This is where we focus in on the new synchronous, not so much the ordered and all of that, but the new synchronous. If you hear a lot of buzz about the synchronous technology, this class is for you. April 5th is Oxford, Michigan. April 12th is Columbus, Ohio. We have NX classes as well. Well, March 22nd, next Tuesday, will be NX for all of our NX people on healing geometry. March 29th, I'll be back with the Solid Edge on time-saving commands. Personally, I think we saved a lot of time today using the smart parts, but we'll go into more in the time-saving commands next time. April 5th, we'll be moving faces in NX. Today's webinar can be found out on our website, camlogic.com. You can see the replay. Go to Galleries, Videos, Tech Tuesday. You'll be able to see all of the Tech Tuesdays, including the scanning and the Z printing functions as well. Also, check us out on YouTube. We have the CamLogic channel out there. We have many, many videos for your benefit. Well, thanks for joining us. Again, my name is Dale Duell, Application Engineer. The number is 740-341-4902. DaleD@camlogic.com. Feel free also to contact us at the Oxford office, 248-969-9201, or at, again, check our webpage out at camlogic.com. I thank you for your time. I welcome your questions and your comments. I also look forward to hearing any suggested topics that you might have. So if you have any topics, let me know. Thanks again.